first part we're going to talk about on a walkie-talkie is the microphone. The microphone is part of the walkie-talkie that hears and interprets the sound waves that come out of everyone's mouth. This part right here is the microphone. That is where all the magic happens.
Black magic.
Okay, anyways, before I was interrupted by Joe, how a microphone works, the sound waves that come out of our mouth enter in through the microphone and hit what's called a diaphragm. The diaphragm has a coil of wire wrapped around it. That way when the sound waves hit the diaphragm, it causes it to move back and forth very rapidly. When this is placed near a magnet, it causes an induced current. That current then carries the encoded sound wave and sends it to the transmitter.
After the microphone, the transmitter generates a continuous uniform AC current, which is transformed into a continuous uniform electromagnetic wave, which is also known as the static that you hear. This is released via the antenna. Current from the microphone is overlaid onto the uniform current, then overlaid onto the radio wave. This is how your voice is sent through the air.
The receiver or antenna on the walkie-talkie takes the radio wave and turns it back into a current. This is sent to the oscillator, which has a capacitor and inductor which only resonates a certain amplitude and frequency. This current is sent to the detector, which separates the current of the sine wave from the current of the sound wave. Then, the current of the sound wave only is sent to the speaker for us to hear.
The next part of the walkie-talkie is the speaker. The speaker is this whole area in here. Now what the speaker does is when the current from the receiver reaches the speaker, the wire is wrapped around a cone. And the cone is inside a circular magnet with one pole around the outside and another pole on the inside. And what that causes is a uniform magnetic field throughout the entire magnet. So as the current through the wire wrapped around the cone is varied, the force from the magnetic field on that wire alternates and causes the cone to move back and forth, causing vibrations which reproduce the sound that was originally spoken into the other walkie-talkie. An additional feature of walkie-talkies is that they have channels where you can separate who you're talking to. Now the way channels work are they make the walkie-talkies operate on different frequencies. For transmitting, this just means that the transmitter creates a uniform sine wave with a different frequency. The FCC limits walkie-talkies to between about 462 and 467 megahertz. For receiving, this means that the oscillator is adjustable, which means so either the capacitor or the inductor inside the oscillator can be made so that the entire oscillator resonates at a different frequency, so it would take in a different frequency. The thing about walkie-talkies, though, is that you can't always ensure your privacy in conversations, because if someone else near you has the same frequency on their walkie-talkie, they can listen to you. Let's see if we can hear any conversations. Huh? We got AMC. Got in some convoy action there. See what else we can find.
Alright, cool. Now that Joe's gone, I'm going to talk to you about all walkie-talkies have a push-to-talk feature. This push-to-talk feature is called a half-duplex system. A half-duplex means your walkie-talkie can only send or receive at the same time. One cannot be on top of another.
That's not.
Okay, good thing it does that because I just saved Kevin from a 30-minute detention.